what we're going to do here today and tomorrow is really more of an algebra 1 review. It was actually in 8th grade a long time ago with the old California standards, but now it's in geometry. So you're going to find this to be more algebraic than geometric, which is fine because we could use a little break. Then on Wednesday, or Tuesday, Wednesday, we'll be doing review for your quiz and then taking a quiz either Wednesday or Thursday. So really fast, you have your next assessment coming up. So let's go through this. Yep. Everything since the last test, including this. Yeah. So it's everything really before the final, and then this one, well, these 2-day lessons. Yep. So, all right. So recall, if two non-vertical lines are parallel, then what? How do we know? How can we prove that these are parallel? Yeah, exactly. And visually, they never intersect. Numerically, what can we prove? How can we say that these never intersect with some numbers? Right? You might recall this, that they kind of go up and over or have the same slope. So if you pick 2 points on the line, let's say here, right, and here, you can see that we go up and over. Actually, I'm going to start right here. We're going to go up and over the same amount. The rise and the run are identical. So pick any 2 points. Make sure they're in the cross section, not in the middle of the squares, but where the two gray lines intersect. The rise and the run are identical. Therefore, the slopes are identical. They're increasing at the same rate. So this has a slope of 2. This has a slope of 2. So they have the same slope. Okay. It's kind of like 2 cars going the exact same speed, but they start like a minute apart from each other. Right? They'll never catch up to one another, right? If they go the exact same rate, start at different points, they never catch one another. They stay the same distance apart. Okay. Now we have another case. If we look over here, where these 2 lines are actually perpendicular. It's a 90-degree angle right here. So if 2 non-vertical lines are perpendicular, what do we know about their slope? So we could pick any 2 lines, calculate their slopes, and tell if they're perpendicular. Up 1, 2, 3. Positive 1 over positive 3. Over here. You can see we go down 1, that's negative, recall, over 3. So we have 2 slopes. We have this slope, which we usually use m as the abbreviation for slope, because it's how the graph moves. So this is negative 1 over 3. This one up here with a positive slope, I can tell it's positive because it's going up, increasing, is positive 3 over 1. So there are 2 pieces of information that let you know if they are perpendicular. First is you can see that one is positive, one is negative. So they have to be opposites. Okay. And second, it's not coincidence that one of them is 3 over 1, the other is 1 over 3. So the other requirement is they are reciprocals. Opposite reciprocals. So we're just going to be doing 2 types of problems, one with parallel lines and finding the equations of lines that are parallel to each other, and then the other, find the equations of lines that are perpendicular or make a 90-degree angle. Okay? And nothing more than that. Just counting some squares first here, and then computing some equations. So looking at these 2, are they parallel, perpendicular, or neither? Now you might be able to look at it, but prove it. So we have up 2, run of 4, which reduces to 1/2. This line has a slope of rise of 1 and a run of 2. Now, I purposely picked 2 points far apart from each other just to help you remember that it doesn't matter which 2 points you pick with slope, they will reduce to the same number. So like if I pick these 2 points far apart from each other, this will be up 3 and over 6, and 3 over 6 also reduces 1/2. So it doesn't matter which 2 points you pick, just make sure they're in the cross section, not like in the middle of the open space in between the squares. Okay, so since the slopes are the same slope, 1/2 and 1/2, then we have parallel. And please make a concerted effort to spell parallel correctly. Just a couple L's, a couple A's. All right, so not too bad. Look at the next. Down 3 over 1. So negative 3 over 1. Up 1 to the right 3. Positive 1, positive 3. So we have 1/3. So are they opposites? Yes, one's positive, one's negative. Are they reciprocals? Yes, so perpendicular. Perpendicular. The abbreviation for parallel, recall, is just 2 parallel lines kind of at a slant like a // The abbreviation for symbol for perpendicular looks like an upside down uppercase T. We can use this notation in the next part. All right, so a little practice. Remember, we want proof, so even if it looks a certain way, we still have to prove it. Show everything. So show the slopes of each line, and then you can decide whether they're parallel or perpendicular. So I can pick those 2, these 2. Okay. So we have, for this positive slope here, we have 3 over 4. And for this negative slope, we have negative 3 down 3 to the right 2. So we do have the opposite, but they are not reciprocals. So this is, and they're not the same either, right? Obviously, one's positive, one's negative, so they are neither. Okay. So by first glance, this definitely is neither as well. They're not perpendicular because you have to have opposite slopes. These are both positive, so there's no way they could be perpendicular, but maybe parallel, but probably not. They don't look like it. Let's prove it. Up 2 to the right 3. And then we have here up 5. Where's that 4? Up 4 to the right 4. All right. So we have 4 over 4, which reduces to 1. And over here we have 2 over 3. Okay. So neither again. Okay. Lastly, definitely they look parallel, but check both slopes. Down 4 over 2. Down, is that 4? 2, 3, 4? Yeah, it looks like it. So down 4 over 2. So we have two slopes of negative 4 over 2, which equals negative 2. Same thing here. So we got parallel. So that's just step 1, which is really a review of parallel perpendicular lines and their slopes. So next, let's look at their equations. Right? We can write equations of these. So first parallel, and we kind of have a little step here of how to go through it. I suggest doing this pretty step by step until it becomes second nature, but there's a lot of mistakes to be made, mostly with negatives. Okay? But there is some review of Algebra 1 in here also. So first off, remember M is the abbreviation for slope. So the slope of the first line we're looking at here that we want to find is negative 1/3. Okay? So the slope of the line parallel to that would be also negative 1/3. So with parallel, these should be the same. Only with parallel, not with every problem. We really have to read the directions and see if it's parallel or perpendicular. Now, to find, so basically we're looking for the equation of a line in slope-intercept form. So we already know that the first part of our answer should look like this. It's going to be y equals negative 1/3 x, and then some y-intercept that I don't know. So what we're about to do next is really to find out what this is, what that y-intercept is. So it kind of helps to know where you're heading. I mean, if you don't get something like this at the end that starts with y equals negative 1/3 x, then you know something's gone wrong. So in order to do this and to find that y-intercept, the step 3, we have to use something called point-slope formula. We have a point, and we have a slope, so it makes sense to use something called point-slope formula. So that was, if you recall, y minus y1 equals the slope x minus x1, where 9 is x1, 5 is y1, and the slope is negative 1/3. So we just have to substitute in those values and watch out for negatives and things like that. So this would be 5, correct? Because y is 5. Slope is negative 1/3. And the x is 9. Now this doesn't tell us what the y-intercept is because we need to have it to be y equals. So we can do some distributive property and some adding on both sides just so we get y equals. Okay, so we can multiply. Negative 1/3 times x is just negative 1/3 x. So that's the first part of our answer that we're looking for. All right, we have the negative 1/3 x. Negative 1/3 times negative 9. Well, negative times negative. Positive. 1/3 of 9 is 3. So 3. So we have y minus 5 is now equal to negative 1/3 x, and then go ahead and add 5 to both sides, and that'll give us the y equals on the left, because I got rid of the negative 5 by making a 0. So 3 plus 5 gives us the y-intercept, which is 8. So that's what we're looking for right here. The y-intercept would be 8. And recall that's the coordinate 0, 8. Y-intercept means when x equals 0 on the y-axis. And we're not going to spend the time to actually graph these, but we're just going to get those equations. But if you wanted to check your answers, you could always do that by using Desmos. All right. So that's the process. It'll get easier the more times we do it. just remember we have to have that slope in order to start. So looking at letter B, doesn't flat out say the slope is negative 1/3, m equals negative 1/3. It gives you the equation. So looking at the equation, what is the slope of that line? It's just 5. Okay. So that's step 1. Step 2, what's the slope of the, I'm going to write it like this, the parallel slope. That's also 5. Okay. And then next, find the equation of the line, and that's this part. Just write out the point slope formula, substitute everything into it, solve for y, and we'll get our equation. We already know, because we have our parallel slope here, my equation for my answer should start with y equals 5x, and then I'm just trying to find out what the y-intercept is at that point. So mostly algebra. All right. Now, the point slope formula does have negatives, right? Or subtraction signs. So what happens if one of our points are negative? Yeah, so we'll end up with like this. The y equals positive 2, so it's still minus 2. Slope is 5. However, we have a subtraction sign from the formula, and then x1 itself is also negative. So we do get double negatives here. Be very careful. And then, of course, double negatives do make a positive. After everything in all these steps, that's the number one mistake, is just watching your negatives. So just be very careful when you're going back and checking your work. If you just check the numbers and the steps only and not really closely at the negatives, you might still miss something. There we go. Now, fair warning for your homework, these numbers, these y-intercepts, may get large or small like that more than you used to, because we're not graphing. So if you get like a y-intercept of 20-something or negative 40, don't think it's wrong just because it's a bigger number than usual. It's perfectly fine. All right, so we got, after all that, we find out that our y-intercept is positive 7. Okay. And then lastly, here's an equation that's not y equals. So the first one just gave us the slope exactly. The B gave us the equation of the line. We had to pull out the slope. But C, we cannot just say, oh, the slope's 3, because we need to have this y equals. We can only say 5 is the slope because we have y equals. This is not y equals, so the first thing is to make it y equals. So yeah, we're kind of putting a week's worth of algebra classes into one lesson right now. All right, what is parallel? What is the equation of a line? How to solve for the slope-intercept form from standard form, which is what this is. So it's a little bit of algebra here. We have negative 3x and plus 4. And now we can say the slope is negative 3. Parallel slope is also negative 3. Then use the slope, point slope formula. Y will equal negative 3x. Just need that y-intercept. Now try this on your own just to make sure you got it down. Don't just copy the screen. You guys can handle this. Use the 2 examples we've done so far to help if you need. I want you leaving here with an idea that you can do this on your own. Okay. So I got, let's see here, 27 plus 6, which is 33. What you guys got? Remember, do it on your own and then check. Should. Yeah. So again, subtraction sign, negative sign. So minus a negative is positive, positive. So I should be subtracting 6 on both sides, which gives me, what, 19? 21? Good job. Yep. And if you just copied it down and you thought, okay, that looks good, that's the warning I was trying to give you. Everything looks so correct, but you miss a double negative, and that throws the whole thing off. So it might look really good. Go back and check the negatives like you heard people doing. Okay, if you're doing it correctly, you're trying this on your own and then checking. Just copied it down and then changed it and erased it. You want to try these on your own. Okay. All right, lastly, let's do some perpendicular lines. So same idea, but the slopes are not the same anymore. So it's very important, by the way, you read the directions. I've had plenty of people that just did parallel for every single problem. They never read the directions. So some will say find the line parallel. Some will say perpendicular. Do something different, right? Don't do the same thing for all of them. So we are given here the slope, which is 4. I'm going to say positive 4. I'm also going to say it's positive 4 over 1. So if it's not a fraction, I'm going to make it a fraction. If it doesn't have a sign, I'm going to put it on a positive because that means it's positive if it doesn't have a sign. And then to find the perpendicular slope, remember opposites, so negative, and reciprocal, 1 over 4. There we go. So the equation of my new line will now be y equals negative 1/4 x, and then I need, that's y-intercept, whatever it is. So no longer the same as whatever we started with. All right, nothing more than what we've done on all the others. Let's see here, negative 1/4 x minus 4 just try this on your own. You can check with mine. Nope, we got a positive here, so it should be minus. Okay. And negative times negative, positive. 1/4 of 4, or 4 divided by 4, 1. And then we can just add 1 to both sides. Okay. And so my new y-intercept is 2. So same but different, right? We don't have any, really, other than step 1 to step 2, everything else entirely the same. So small but important distinction. And just like we saw at the very beginning, we can't have perpendicular lines if they're the same sign. So if you're doing perpendicular, if your original is positive, you know your new should be negative, and vice versa. All right. Now here, just like above, the slope is not given, right? Because we don't have y equals, so that's the first step. Get y equals, divide by whatever is in front of y, the coefficient of y. So now we have y equals -2/5 x plus 12/5, or 2.4. It's not important. We're not graphing it, so it's not too important that that's a fraction y-intercept. We're just finding the equation perpendicular to it. All right. So we know the slope here is -2/5, right? What is the perpendicular slope to that? Perpendicular slope. Opposite, positive, reciprocal, 5/2. Then we can go ahead and graph or solve. Point slope. So we have first part of our equation, we know y equals positive 5/2x, and then some y-intercept. The rest is entirely the same. So after you do enough of these, you really see the repetition. It's a lot of good review, mostly watching out for negatives. So I'll have y plus 8 because it's y minus -8 here. And then the slope is 5/2. X plus 6, right? Because it's x minus -6. Okay. All right. Distribute 5/2 times x, 5/2x. 5/2 times 6. Now, if this bothers you, if doing 5 times 6, getting 30, and 30 divided by 2 is 15, if that bothers you, please use a calculator. You don't have to worry about missing any algebra problem or geometry problem for the rest of your life because you're allowed to use a calculator on everything. So simply missing this because, well, I'm not good at fractions is absolutely not acceptable. That's more like declaring, I'm too lazy. I could get the right answer. I'm choosing not to. There are devices that I'm allowed to use. I'm just choosing not to use them for some reason. It's completely in your hand. So again, we just did 5 times 6 and divide that by 2. Two things you learned in elementary school. 3rd grade, really. You learned 5 times 6. 3rd grade. How to divide something by 2. 3rd grade. So we cannot say that this is too hard or too difficult. Please do not tell yourself that. Most of the time, people that are saying that are just repeating what they've been saying for a long time. Once they actually try it, they're like, oh, I can do this. Just been caught in a bad habit of saying I can't myself. So, yeah, it's not too bad. But even if you don't trust yourself, you're like, I still don't think so. You got a free tool that you're allowed to use that gives you the correct answer every single time. So, utilize. All right, so there we go. Y-intercept is 7. I think this is no different. So if you want to go through here, we can just talk this through. First step, what's the slope? Okay. What's the perpendicular slope? -2/1. And you can just use -2. We don't have to use the over 1. And then you plug it into point slope. And then lastly, you'd have your answer, which is going to be of the form y equals -2x, and then whatever you get from that formula at the very end. Okay. It does become easier. Just watch out for negatives. I always like to think them as being opposite signs. So if it's a positive 3 in the point, it's going to be minus 3 in the formula, right? And if it's minus in the point, it'll be positive in the formula. That's what a subtraction sign does. It takes the opposite, so it's no coincidence that it's the opposite signs as you see here in the formula. The negative 2 is now plus 2. The positive 3 is minus 3. All right. And it does get easier. Just keep on repeating. Don't skip any steps. There we go. Equals, what's that, minus 4? We can add 3 to both sides. All right. Negative 4 plus 3 is? Negative 1. There we go. And obviously, if I did the point slope and it doesn't match the first part of the equation, then something's wrong. Don't even put a number here yet. So that's that needs to happen as well. All right, now I have given you both 27 and 28. 28 is kind of like one of those little more fun worksheets where the answers are on there already, and you just have to fill out, solve some riddle by filling out the numbers and letters at the bottom correctly. Now, if you want to start with that one because the answers are there, that way you'll know you're doing it right, that's fine. I'm not going to check this tomorrow. So if you want to do 28 and then 27 tomorrow, and then I'll check them on Wednesday, that's fine. That way you'll get to do a few of them, know you're doing them right, and then you can do the part where there are no answers given to you. That's perfectly fine. And usually, like I mentioned, if you're getting them wrong, it's more about negatives than anything else. If you don't show your work, this is a fun thing that teachers have not figured out in a million years, how to get students to show this no matter what. If you do this on every problem, you're probably not going to miss it, except minus maybe a negative here and there. It's after showing you how to do this, are you still going to do that, or are you going to try to cram all the work in on those little tiny lines where there's no space? So use it on a piece of paper if necessary. If you show all the work, write big and neat, you're probably not going to miss a whole lot. Okay? It's mostly just handwriting and negatives that get in the way of getting these correct. So, all right, so that's it. You have a review to do also tomorrow for your quiz, and then you'll have a quiz coming up Wednesday or Thursday. All right, so you got some time to finish this up today, and we are done.